Okay, number 10, it just says, is y equals 3 a function? Yeah, I don't know why they threw this one in here, but since they did, we'll talk about it a little bit. Y equals 3 means no matter what x value you use, there's always going to be y equal 3. So y equals 3 would have like the point 0.03 or 1.3 or 2.73 or negative 5, whatever x value you use, the y value is always 3. Is this a function? Yes. The x value changes, doesn't matter if the y value doesn't. So number 10 is just yes. You guys know what that would look like on a graph?
Horizontal line.
Yeah, like 0, 3, 1, 3, 2, 3. Yeah, it's all these points. This is what y equals 3 looks like. We're going to need to know that for next chapter. You guys remember slope and y-intercept and all that stuff? I think that's coming up. All right. Number 11. Make a table at least 5 ordered pairs for y equals 3x minus 5. Is it a function? Okay, usually we made the tables when we were graphing. It doesn't ask us to graph this. So, this is what they mean by table, like an XY table. Now it says 5 ordered pairs, so what x value should I use?
-2.
Well, since we're not graphing, even if you are graphing, you don't have to use those. But I would just choose maybe the 5 easiest, 0 through 4. Negatives kind of confuse people. Doesn't matter though. It just said use 5. 0 is usually pretty easy because 3 times 0 is 0 minus 5. Y value is -5. If I plug in 1, 3 times 1 is 3 minus 5, -2. By the way, I've just finished grading all you guys' homework. On that absolute value assignment, some of you didn't catch this. After you plug the number in, and in this case you'd have to add 7, then you make it positive. You have to use absolute value to make it positive. This one is not absolute value, I'm just saying. 3 times 2 is 6. Most of you got it right. 3 times 2 is 6 minus 5 is 1. 3 times 3 is 9 minus 5 is 4. 3 times 4 is 12 minus 5 is 7. They did not ask us to graph it. But they did say, is it a function? Yeah, all the x values you plug in, I'm only going to give one answer. Okay, do I need help on 12? What's 12 mean? Find f of 4. No. Means plug in 4 for the x value and see what comes out. Kind of like I just did on this last one. Plugged in 4. All right, 13. When no domain is stated for a function, what is the assumed domain? When they don't tell you what to use for x, what can you use for x? Yes, anything. Or whoever said it, I'm thinking Avery. All real numbers. If they don't limit the domain to a few numbers, then you assume it's unlimited.
So for 12, would you just need to put what that equals once you plug it in? And that's the answer, or?
Yeah, this is pretty basic. Okay, 15. Domain and range of the graph. I don't know if I want to draw that. Looks something like this. Okay, domain meant what again?
The starting place?
It means the x values that we're using. Domain is the x values that we're using. So every point on this line has an x and a y value. So what x values are included? Well, there's an infinite number of points. We're not just using whole numbers. There's decimals and infinite decimals and fractions. So there's actually an infinite number of, so we can't just say x equals -2 or x equals 1. It's all the numbers from here to here are all the x values that are covered. Okay, what's that leftmost point's x value on that graph? -4. Okay, so we're just thinking x values, so we're just thinking left to right. What's the, kind of like a number line, what's the rightmost point's x value?
3.
Is it 3? Okay, are all the x values in between here filled in?
No.
Yes.
Yes.
Okay, now is -4 and 3 filled in? No. So -4 and 3 are not part of the solution, but they're like the boundaries. So all the x values from -4 to 3 are used, not including -4 and 3. How did we write that? -4 is less than x, which is less than 3. Okay, so range is so notice I put less than, not less than or equal to, because the circles were open. -4 and 3 are not included. The range is the y values. So y values go down and up. So we got to think vertically. So what's the lowest y value over here?
-3.
-3. Okay, I'll put it over here. And what's the highest y value?
4.
Is it 4? All right. So kind of the same thing as the x values. Are all the y values from -3 to 4 filled in? Yes. There's a y value for every number between -3 and 4, somewhere in here. So we're kind of the same thing. The numbers are a little backwards though. But the y values run from -3 to 4. Are -3 and 4 included? No. The open circle means no. So same thing, but this time it's -3 to 4. And go ahead and put y in there for the range instead of x. Alright, does it ask if it's a function too? Yes. Is it a function? Do you guys remember how we tell on a graph? Does it? Right. Does it pass the vertical line test? Anywhere we draw a vertical line, does it hit twice? No, so that means it does pass the vertical line test. So yes, it's a function. So don't forget those yes, no's on 14 and 16.
16 is the same, right? Like it's 15.
16 is going to look like 15 because it's a continuous set of points. But 14 will not look the same as 15. How would we write the domain on 14, for example?
-4, -1.
Yeah, you'll just list numbers. Like the point on the left has an x coordinate of -4. The next point over is has an x of -1. So we just listed numbers like d equals, kind of like number 7. All right, 17. Graph the relation. Say whether it's a function. I guess I'll jump to my graph paper. All right. Y equals 2x minus 4. They, what color you guys want?
Purple.
Let's do purple. Let's see, y equals 2x minus 4. Okay, they do give us a limited domain on this one because they say x equals 0, 2, and 5. So it's not like use whatever you want to. It's only those three. So, if I put in 0 for x, 2 times 0 minus 4. Y is negative 4. If I plug in 2, 2 times 2 minus 4. Plug in 5, 2 times 5 is 10, minus 4 is 6. So, on the graph, it's kind of going from 0, negative 4. 0, negative 4. 1, 2, 3, 4. Where's 2, 0 at?
Which word it is?
2 to the right, and then 5, 6, 1. Do we connect the dots? No, because the domain is limited to just those 3 points, not every point. Should be in a straight line if I did it right. Did I count right? 2, 3. No, that's about right. Is it a function?
Yes.
Yes. Definitely passes the vertical line test. Only hits at one point anywhere you draw a vertical line. Okay, I'm gonna have to they threw another weird one in here. On 18, they want you to graph x equals 2. Well, do you guys remember what happened on 10 when it was y equals 3? What that meant? It means the y value is always 3. So what does x equal 2 mean? Means the x value is always 2. So like 2, 0, 2, 1, you know, whatever, 2, negative 1. What does that look like if you graph it?
A vertical line.
Yeah, and you guys might remember that from last year. 2, 0, 2, 1, 2, negative 1, and you know, all these. So this domain is unlimited, I think. Or actually, no, they said from 2 to 5. So they actually did say only use numbers from like 2 to 5. So another. So 2, 2. Said only use y values from 2 to 5. 2, 3, 2, 4, 2, 5. So it would look like that. It'd be a vertical line still, but it just stops. Alright, is that a function?
No.
No. It fails vertical line test. Hits at infinite points, actually. Points don't have any size. They don't take up any space. So you can fit infinite points between any two other points. You can fit an infinite number of points. It's kind of like if you do like what's halfway between 1 and 0 is a half. What's halfway between that? What's halfway between that? What's halfway between that? You keep getting smaller and smaller and smaller. Infinitely. Alright, are we skipping? No. 19, and then 20, and then we're skipping a couple.
They are?
Somebody erased. Probably me.
We're not geometry, Mr. Jordan.
Oh, whoops. Okay. Never mind. 1 through 30. Yeah, let's go to like 24. We'll go to 24 for the minute. Okay. Interpret each graph. Explaining the labeled section.
We set up 2:30 to
No, it's 2 days. Same. So on the graph, the bottom is minutes, so it's time like normal. And what's the y-axis represent? Temperature, degrees Celsius, yeah. Temperature. So, it's talking about the temperature of water over time. So what's happening on A?
It's ice melting.
It's freezing. Yeah, you could say it's approaching freezing but warming. I'll just leave it as freezing then. Okay, at B, what's happening? Yeah, do you guys remember 0 degrees Celsius is freezing? Anyway, at B, what's happening? Stays at freezing. Yeah. Actually, outside, if it's 32 degrees out, like in Fahrenheit, but the sun is shining, it will still melt. You guys notice that? The sun still melts it. All right, see what's happening. Heating up all the way to 100. Do you guys? What happens at 100 degrees Celsius? Boiling. So I'm just gonna put heats up to boiling. And D stays at boiling. E heats up even more. It will start to, but that's they just put temperature rises quickly. All right, 21. You don't really need graph paper for these sketches. I mean, you can put it on graph paper, it doesn't really matter, but sketch a graph of a man's heart rate over the course of an hour in which he mows the lawn with a push mower for 20 minutes, he rests for 15, then he lifts weights, and then he reads. So he kind of like push mows, so that's hard work, and then he rests, and then he lifts weights, so that's hard work, and then he rests, he reads. So what's the x-axis going to represent? Time. And what's the y-axis represent? Heart rate. You guys know what a resting heart rate is?
98.
98 was really fast. Maybe 70 or 65 or something like that. Okay, so he starts off mowing. So when he starts mowing, it's going to be low. But then it'll pick up. And then it should level off, though, because once you get your blood pumping, it's not going to keep going up forever. And then he rests, so it'll slow down for a little bit and stay down. And he lifts weights. Probably the same thing happens, and then he reads.
Weights is a little easier than mowing the lawn, I think, or a little bit less of a heart rate.
Depends how you do it. Yeah, push mowing can be. Yeah, it can be easy.
It depends if you're inclined or not.
Like, it depends if the mower self-propelled.
Okay, anyway, we're not going to be that picky. We just need two hills on the graph. Okay, 23. Well, shoot. On 23, you have to use your graph on 22. But we can kind of look at the table probably to figure it out. So 22, you're supposed to graph that table on the right. So on the bottom, probably want to put the miles. Usually we put the first variable on the x-axis, miles traveled on the bottom, gallons of gas used on the y-axis. What might you count by for the miles? I'd probably count by at least 50 because you need to go up past 330. So 750s would get you to 350. So yeah, I would count by at least 50s on the miles traveled. On the gallons of gas used, maybe count by like 2s or something like that. 3s maybe. Anyway, I'll stop there.